3.7, investigating graphs of polynomial functions. Polynomial functions are classified by their degree. The graphs of polynomial functions are classified by the degree of the polynomial. Each graph, based on the degree, has a distinctive shape and characteristics. All right, this is a linear function. You'll notice the linear function is a straight line. Who would have guessed? It's a degree 1 because it's only 1 degree polynomial. This would be like the function y equals x. It's a linear function. Degree is the highest exponent. In this case, it's a 1. So our degree is 1. Linear functions always form a straight line. That's the word. Second is a quadratic function, degree 2. We should probably go back to the linear to discuss something. You'll notice the linear either goes from left at the bottom and up to the right. You could also go left to right and down, and that would be if we had a negative number in front of here. If I'm looking at a quadratic function, this one is up on this side and goes up on this side. This has a degree of 2. This would be like y equals x squared. A cubic function has a degree of 3. That's y equals x to the third. And if you'll notice this one, they go in opposite directions again. So it's going up and to the right, then goes down and back up. But you'll notice that if I'm looking at the ends, on the left side it goes down, and on the right side it's like ka-chow, and it goes up. The next is a quartic function, which has a degree of 4, and it's up and up on the ends, or it could also be down and down. Next is a quintic function. This is my favorite one, and it has a degree of 5. Anybody? Yeah, quint. It's kind of like my name. The end behavior is a description of the values of the function as x approaches either infinity or negative infinity. So as our x's either get larger and larger or smaller and smaller, looking at negative infinity, that's how our end behavior will work. The degree and leading coefficient of a polynomial function determine what its end behavior is going to be. It's helpful when you're graphing a polynomial to know about the end behavior of the function. Okay, so the polynomial has an odd degree. In other words, x to the third, x to the first, x to the fifth. Then as x approaches infinity, your polynomial or your function will also go to infinity. So as my x's get further and further out, the y's will also go further and further up. Additionally, as x goes to the negative infinity, then the polynomial will go to negative infinity. Now this only works whenever our leading coefficient is greater than 0. So if it's a negative, then it's going to make it the opposite, which we'll see in the next slide. If we're talking about even degrees, as x goes to negative infinity, so as my x's get further and further away from the y-axis, then my y goes to infinity as well. And as x goes to infinity, my y goes to infinity.